Hello, class. So we are now in section 1.7, which is about inequalities. Okay. And so section 1.7, basically we learned about equalities a couple sections ago. So now we have to learn the inequality version. Okay. And a lot of it's the same. So here I have an inequality. I'm allowed to add to both sides and everything is fine. Okay. I'm also allowed to subtract to both sides. Okay. So adding and subtracting to both sides, fine. And it doesn't matter what kind of inequality. If these were just regular less thans, if they were greater than or equal to, okay, they're all kind of the same. Okay. So allowed to add and subtract to both sides. That's good. The second thing is if you have a positive number, okay, and A is less than B, then AC is less than BC. Okay, so if you have a positive number, you can multiply to both sides like normal. That's fine. Okay, now we get to the special rule, the most important. Okay, and that's if you have a negative number. If you have a negative number, then when you multiply to both sides, okay, you actually have to flip this inequality. Okay, it goes the other direction. And just like let me kind of like prove it to you in like this small example, right? 2 is less than or equal to 4, right? We all agree? Great. Let me multiply both sides by -2. So you get -4 is less than or equal to -8. And then you think about this and you're like, wait, that's actually wrong. Well, right, you have to flip it because -4 is actually bigger than -8, okay? So that's the reason that 3 exists, okay? Now other ones, these last two are kind of just special. Not that important, but I should tell you them. If A and B are both positive, really it's if they have the same sign, but let's not get picky. Then 1 over A is greater than 1 over B. So what this means is like the bigger the number on the bottom, the smaller the actual fraction, right? Like 1/2 is less than 1/3, which is less than a fourth, which is less than a fifth, and so on, right? The bigger the number on the bottom, the actual tinier the fraction, okay? All right, and then the last one, if A less than equal to B and C is less than D, then A plus C is less than or equal to B plus C, okay? And this also, I hope, just makes sense, right? If I have two numbers that are smaller than two other numbers, if I add them, then they're both gonna be still smaller, okay? All right. Now, if you let me get philosophical here for a little bit, um, the solutions to equations, right? So we did equations 2 sections ago. And if we remember, like, what were the answers, right? The answers to equations were numbers, right? Like 2, 1 plus square root 5, right? Those things. So now that we're dealing with inequalities, okay, what are the answers? The answers are sets, okay, not numbers, okay? So since the answers are sets, that means we're going to need to use interval notation, okay? And that's why when I introduced interval notation at like day one, I said it would be very important. Okay. So there's going to be a lot of examples in this section. All right. We're going to start off with an easy one. So a linear inequality. Okay. So this thing. All right. We can solve this like normal. Okay. So just, subtract the 9x to both sides. Then we're going to get negative 6x less than 4. We're going to divide by negative 6. Right, and then remember, we have to flip because I just, multiplied by a negative number or divided. And we get negative 2/3. And ta-da, that's the answer. Okay. Now in interval notation, that means it's negative 2/3, comma, infinity, right? All the numbers bigger than 2/3. Okay. So for linear stuff, inequalities are basically just equalities. You don't do anything special. Okay. And just to make it a little more complicated, okay, so let's move on to the next example. 6 less than or equal to 3x minus 2 less than or equal to 16. Okay. Actually, let's make this 7. Okay. So, here I have like, right, there's like a double inequality. What do I do? Okay. Well, when we had equal signs, right, we always add to both sides. That's the rule, right? When we're adding and subtracting. So now that we have like, 2, you could just think about it as adding to all sides. Okay. So my first step is I want to get rid of this 2, right? Because I want to solve for x. So I have to add 2 to all 3 sides. Okay. And then so we're going to get 9 less than equal to 3x less than equal to 18. Okay. And then divide by 3. We're going to get the answer 3 less than or equal to x less than or equal to 18 divided by 3 is 6. Okay. And this is pretty easy, right? So we have less than or equal to's. So that means brackets. And then 3, 6. Okay. So there you go. Not too difficult. Okay. Now we're going to escalate a little bit into quadratic inequalities or polynomials that are bigger than line. Okay. So I want to know, when is this true? Okay. And this is when I'm going to introduce the concept of critical points. Okay. So I do this and rational inequalities a little bit differently than your book. So feel free to, if you like it, use this way. If you don't, go learn a different way. Use the textbook way. But critical points, for us, right now, they just mean zeros. Okay. So I'm going to move everything to the left. That's already done. And now I'm going to factor. So x plus 3, x plus 2. Right? And if this was inequality, I'd be done because I'd be like the answers are negative 3 and 2. Okay? And negative 2. Okay. But instead of that just being like the answers, right? These are the critical points. And now I have to make a sign chart. Okay? Because I need to write the answers are not numbers, the answers are sets. Okay? So I'm going to put the critical points on a number line. And I need to check where's the answer. Is the answer here, here, or here? Okay. There's 3 places the answers could be because the critical points kind of split the number line into 3 parts. Okay. And what you do is you just plug in test points. Okay. So I'm going to plug in the number 0. So check 0. So if I plug in 0 into this, I'm going to get 3 times 2 equals 6. Is that less than or equal to 0? No. So this is not my answer. Now I'm going to check like negative 2.5. Okay, which is a little annoying to check, but it's okay. So if I check negative 2.5, I'm gonna get actually I'm gonna get 0.5. Okay, 0.5 times negative 0.5, which is negative 2.5. And is that less than or equal to 0? Yes. So this middle part is definitely my answer. And now I have to check over here. And I'm going to check negative 4. Okay. I plug in negative 4, what happens? I get negative 1 times negative 2. That's positive 2. And that's not true, so this is not our answer. So this is our answer. And that interval is negative 3 to negative 2. Okay. All right, so for polynomial inequalities, you basically find the zeros and then do this sign chart thing. So it's kind of just like an extra part at the end. Okay. Now, let's do another one. Okay. All right, so I want to know when this is greater than 0. Okay. So, first of all, this would be very hard normally, right? This is a, what is this? This is a 7th degree polynomial if I FOILed it all out. So frequently in this section, we'll either make him small, like this quadratic where you can factor it, or if we make them big, we'll give them to you automatically factored. Okay, so we can just stare at this and find the critical points, right? It's 0, 1, 3, and negative 2. Okay. Now we just have to make the sign chart. Okay. So you stick all of these numbers on there appropriately. All right, so there's my sign chart. There are my 4 zeros or critical points. And now you just, check. So I'm gonna check 4, okay? But if we want to get a little faster, okay, because this could be a little slow, notice that like this is 0, right, on the greater than or equal to sign. So really all I care is if the number is positive, right? So when I plug in 4, right, this will be 4, but that's a positive number. When I plug in 4 into this, that's 3, but I'm just going to think about it as being positive. This, when I plug in 4, will also be positive, and this will be positive. So all of this is positive, so that's good, because I want greater than 0. So this is part of my answer. Okay, and that way you get to like save some brain power, right? You don't actually have to crunch these numbers. But if this is a little confusing to you, then feel free to still plug in numbers. Okay, so now I'm going to plug in 2 plus plus. Here I'm going to get a minus sign, right? This is a plus. So when I multiply all of these together, you're going to get a minus sign, which is bad. So not here. Okay. Now I'm going to check 1/2. Okay. So this will be a plus. Okay, now here you got to think about it a little bit, right? This will get me a negative 1/2, but it's squared. So actually this term will always be a plus. This will get me a negative number for sure. And then this will get me a positive number. So 3 pluses and a minus is a minus, so this is bad. All right, now I could leave this plus here actually. It's always a plus. Now I'm gonna check -1, I guess. Okay. So now this is negative. This is also negative. This one is still positive. So 2 minuses and a plus. That's positive. So this is part of my answer. And then lastly, I'm gonna check like -3. What happens? That means this one becomes negative, and then the whole thing is negative, which is bad. Okay. So we see that these are my answers. Okay, so in interval notation, that would be -2, 0, union 3 to infinity. Okay. All right, and there's technically very fancy things you could do involving multiplicity, okay, that we don't teach you really in this class anymore. But if you notice, like, no, yes, no, no, yes, right? Like there's a pattern, like no, yes, no, right? The pattern is if the power is odd, okay, it'll switch signs, okay? So you see how like at this 3, this is odd, so it switched. At this 0, it's odd, so it switched. And at the 2, this is odd, so it switched. When it's even, it stays the same. Okay. That's a very, very fancy trick. So, use at your own caution. But that'll speed you up a lot faster than having to check all of these numbers. Okay. Parentheses. Okay. All right. Now we're gonna do something a little more difficult. Okay. And that is rational inequalities. Okay. So really, it's the same thing, but just a little harder. Okay. Um, Step 1 is automatically when you have a rational inequality, anything that makes the denominator 0 is automatically a critical point. Okay. So 2 is automatically a critical point because it's like not in the domain and it causes things to explode. So it's already important. The next thing I do, which is different from what most professors like to teach, is I actually don't like to do anything with this. I like to pretend it's an equal sign, okay? Because the other critical points are the zeros, which we already know how to solve these things from a previous section. So let's just do that. Okay, so you get -x plus 2 equals x minus 2. And then you get -2x equals -4. And then you get x equals 2, which we already wrote here, but it is again a critical point for another reason. All right, so now that we know our critical points, all of them, right? It's 2. We're gonna make our sign chart. Okay, so only 2, and I have to check. Right now I plug in, so I'm gonna plug in 0. 0. Okay. And so I need to plug 0 into this original equation and see if it's true. And like notice now this isn't just a 0 on the right hand side. So you might want to actually plug in to check, right? So if I plug in 0, you're gonna get 2 over negative. So you're gonna get -1. Is -1 greater than 1? No. Okay, so this is not my answer. Okay. Now I'm going to check like 3. Okay. So if I plug in 3, I'm going to get negative 3 plus 2, which is negative 1, over 1, which gets me negative 1 greater than or equal to 1. Is that true? No. So actually, this is just never true. All right, the answer to this is no solution. Okay. Or, I mean, if you want to get like really technical, the answer is the empty set, which we write like with the 0 with a slash through it. But it's possible that there's no answer. Okay. Highly possible. And this is just an example. All right, so moving on. Here we're gonna get a little more fancy. Okay. And so again, automatically we have some critical points. Okay. And it's going to be negative 3. And then from here, I'm just going to off to the side, figure out what that critical point is. Okay, so the critical point is negative 3 again. Okay, that's funny. Actually, I just noticed this. This is your textbook is being a little bit weird here. You could totally factor this thing, right? Take out, this is 4 times 2, and take out a 2 from this, and cancel. So actually, your textbook should have written this. Okay, they're just trying to annoy you. That's okay. All right. And now we can actually do something very nice. Okay. I'm gonna actually do this in your book style, not my style. So I'm gonna subtract over and get a 0, like you know, kind of like how we do with polynomials. Okay. So minus 4x plus 3 greater than or equal to 0. Okay. And then we already have a common denominator, which is the reason I'm doing this, because it's so nice. Okay, so since we already have a common denominator, we have this. Okay, which hopefully you notice. Okay, hopefully you've paid attention to the you know factoring section, and you can see that that's a difference of squares. So x plus 2, x minus 2, x plus 3. And so you can see that the other two critical points are negative 2 and 2. Okay. So now that we have our critical points, let's do the sign test. Okay, so we have negative 3, negative 2, and 2. Okay, obviously this is not drawn to scale, but that's okay. Right. Now, my pen is having technical difficulties. All right, only black for the rest of the class. All right, so plug in 3. I'm gonna plug in 3. What happens? So if we look at this thing, I'm going to get a positive number times a positive number divided by a positive number. That'll be a positive number, which is good. So yes. All right. Now to test here, I'm going to check 0. Okay. And if you check, it's going to be negative. All right. And then if I'm going to plug in something in between here, that probably is going to be negative 2.5. But I'm actually going to use the multiplicity trick and know that, oh, that has to be a positive, okay? And then now I have to plug in like something over here, which I'm going to actually plug in -4. So then, right, we're going to get a negative and a negative and a negative, okay? So 3 negatives is negative. And that is not greater than or equal to, so this is not an answer, okay? Oh, not, yes, okay. If you want to put pluses and minuses on your sign chart, that's also okay. But we see that the answer is -3 to -2. These should be brackets, okay? Because it's a less than or equal to. Union 3 to infinity. And actually, this is a very good part. Can I? Nope. Nope, okay. Actually, I cannot just put brackets like normal, right? Because if we go all the way to the top, right, we remember that -3 is not in our domain. So even though this is a less than or equal to, I can't actually plug in -3, right? Because then this thing blows up. So you need to put a parenthesis here, okay? Because -3 is not in the original equations domain or inequality, okay? But the rest get brackets, right? Okay. So hopefully you get this, all right? The sign chart, very important, very required, okay? No matter what you do, you kind of need the sign chart. And so now we're going to move on to the last part of this section, which is absolute value inequalities. Okay. Which is honestly not that hard. What you do is 2x plus 1 less than or equal to 8. So if you remember the equal sign version, you split it into 2, and you do the same thing here. And if you remember the equal sign version, you know that for the first case, we just get rid of the bars. We don't do anything. For the second case, right, I told you to put a minus sign on the right-hand side. And now, okay, now you also flip the inequality. Okay, so that's 2 things you have to do. You have to put a minus sign and flip the inequality. Okay. But then you just solve like normal. So -1, -1, 2x less than 7, x less than or equal to -7/2. Here, you're gonna get -9, x greater than -9/2. Okay. And so if you put these together, right, I need something bigger than this number and smaller than this number. So you can actually now recombine them into this. Oh, in equal to, okay, 7/2, and then the interval notation is obvious, right? 9/2, 7/2. Okay. And if it's absolute value less than number, then it'll always be in one interval, kind of like this. All right. Now, the opposite thing is kind of true when you have the absolute value with a greater than symbol. Okay. So you do the same thing. All right, you're gonna get rid of the bars and do nothing. And over here, you're gonna flip the sign and then put a negative. Okay. And then you solve like normal. So 16 over 3, 3x Adding a 4, so that's 8. -8. All right. And here you notice, like, right, you need a number bigger than this one, but less than this one. And right, if you look at a number line, so if you draw this out, what does that look like? Right, that looks like this. Right, it's like the opposite of this one, right? Here it's like a contained little portion. Here it's like the opposite of the inside chunk, right? So an interval notation, that's parentheses, negative infinity, -8/3, 16/3, infinity. All right. Okay, and then now, unfortunately now, okay, hate to do this. Okay. Nope. All right. This section also has a word problem that you should know how to do. Okay. So actually, this word problem is something that I hope you guys just do when you guys like go grocery shopping or something like that, right? Like it's like a compare problem, right? Like what's cheaper, what's more expensive. Okay. So here we have a hypothetical carnival ride. Okay, that sells 2 tickets. Okay, plan A and plan B. All right, and plan A is a $5 entrance fee. Plan B is a $2 entrance fee. Okay. And with plan A, it's 25 cents to ride each ride. Okay. But for plan B, it's 50 cents to ride each ride. So we see that, like, right, plan B is cheaper if you ride less rides. But eventually, if you ride enough rides, plan A will be cheap, right? And so the question is simple: which one's better? Or like when is plan A better? Right? Very natural question. Okay, so first you're gonna make some equations or some models. So plan A, right, or the cost of plan A. I guess I should put cost. Cost of plan A equals 25 cents times the number of rides you ride, which I'm going to call R, plus $5. Okay. The cost of plan B is 50 cents times each amount of rides plus $2. Now you set up an inequality, right? So when is plan A better? So that means when does plan A cost less than plan B? Okay. So I'm just going to write down the math. And we see that we get a linear inequality. Okay, and that's why this is in this section. Okay, so I'm going to solve. Okay, so I'm going to subtract the 2 and get a 3. And then I'm going to subtract the quarter and get a quarter. Then I'm going to divide. So okay, so actually 3 divided by 0.25 less than equal to R. So this is 12. So when R is greater than or equal to 12. Actually, if we want to get like super technical, I should not have put a less than or equal to. So because at 12 rides, plan A equals plan B. So they're the same. If you plan on riding 12 rides, then it doesn't matter which ticket you buy. You're gonna spend the same amount of money. Okay. But for more than 12 or after 12 rides, after 12, plan A becomes cheaper. Okay. And I mean, for this kind of problem, you don't even need the fancy math though, right? Like like this is what I would do. But I'm assuming what normal people do when they actually want to figure this out is they just start plugging in a bunch of numbers, right? Like you're like, how much does it cost if I want to ride 13 rides? And then you just start like moving the number up and down, right? Eventually getting the correct answer. But that's okay. That's okay too. So that's it for this section, kind of long, okay? The most important thing is definitely these inequalities with the sign charts, okay? But that's it for section 1.7. All right, I'll see you in the next section.